Hello everyone, in this lecture today we will be talking about IP addressing. So what are IP addresses? IP addresses are 32-bit identifiers for every host and router interface. Now each router or host can have multiple interfaces and there is an IP address associated with each interface. So the interface is the important thing. There is not a single IP address associated with the host. There is a single IP address associated with each interface at the host. Okay, so it's a 32-bit identifier, and here is an example of an IP address. So here you have 223.1.1.1, and 223 is converted into an is converted into 8 bits. This is the binary representation out here. That is 110, 11111. And then there were another 8 bits for 1, another 8 bits for 1, then another 8 bits for 1. So this is a 32-bit identifier, and it's broken up into 4 chunks, each of 8 bits. So because there are 8 bits in each of these 4 chunks, the maximum value that can be represented with 8 bits is 255. Okay, so we just said that interfaces, that there are IP addresses associated with interfaces. So the next question is how are interfaces connected? So we'll actually learn about that in the link layer. For now, all that you need to know is interfaces are connected to the intervening router using switches. Here is an example of an Ethernet switch where all these computers are connected to this router here using this Ethernet switch. Similarly, you can also be connected to a router via a switch using a wireless connection. So both these laptops here are talking to this router wirelessly using Wi-Fi. Okay, so but for now, as I just mentioned, you don't need to know about how the interfaces are connected. All that you need to know is each interface has an IP address associated with it. Okay, so what is an IP address? So so let's get into a little bit more detail. So as I mentioned, IP addresses are 32 bits long, and they're both broken up into 4 8-bit chunks. So here 223.1.1.1 is an IP address. This machine has an IP address called 223.1.1.2. But IP addresses are a little more deeper. So in the sense that there are 2 parts to an IP address. The first part is the subnet part. That is the high order bits. The higher order bits form the subnet part, and the low order bits form the host part. So what is a subnet? Now devices, interfaces with the same subnet part are together form the subnet. So what does that mean? Here, if you look at these 4 routers here, all of them have 223.1.1. They all have this common, 223.1.1. It's common for these 4 interfaces. What changes is this first machine here has 1, the second machine here has 2, this one has 3, and this one has 4. So these 4 computers together are connected in this subnet, or more specifically, these 4 interfaces form a part of this subnet. Similarly here, 223.1.3 is common to each of these 3 interfaces, and where they differ is in this last 8 bits, where it's 1, 2, and 27. So these 3 interfaces together form another subnet. So in this particular example here, there are 3 subnets. So why are subnets important? Why are we introducing them? The fact is, hosts that are connected within a subnet can reach each other without an intervening router. So all these hosts, or basically all these interfaces, can be reached without an intervening router. Typically, they could be reached via switches. Okay, so let's get into a little bit more depth about subnets. So how do you identify subnets? So the easiest way to identify subnets is to detach the interfaces from the host. So here, each of these computers only have a single interface, but this router in between has 3 interfaces, and it has 3, and each of these interfaces, as I mentioned, has a different IP address. So what you want to do is you want to detach each of these interfaces, and then you can group these interfaces together. Now if you group these interfaces together, what you have is 3 subnets for this particular network. Okay. Now There's a new concept that you also want to know is what is called a subnet mask. So here the subnet mask is 24 in the sense that these bits are all the same. So that is why there is 24. So the first 24 bits are going to be common to for each host that is a part of the subnet, and other hosts which are not and the remaining 8 bits are going to be could potentially be different among all the hosts that could be part of this subnet. So as this is the subnet mask is /24, that means the last 8 bits could be different, and as a result the number of hosts that could be connected to this subnet is is equal to 256, because there are 8 bits and those can be assigned to the different hosts, and therefore you could have potentially 256 hosts in a particular subnet here with subnet mask 24. So what I want you to do as part of the exercise is try to determine the subnets in this particular network. The clue that recall that what I said earlier, that you would like to detach the interfaces from the routers. For example, this router here has 3 interfaces. You would want to detach them and then find out those particular interfaces which are similar, in the sense that their higher order bits are similar, and you would want to group them. So what I'm asking you to do here is to determine the number of subnets that are there in this particular network. Now that we looked at subnets, we come to this new concept which is of IP addressing called CIDR, or classless interdomain routing. So in classless interdomain routing, this is how the subnet, you have the addresses in the form of a subnet and its mask. So basically addresses would be written in the form of a.b.c.d \x, where x is the number of bits which is the subnet portion of the address. So for example, here you have 200.23.16.0/23. This means that the first 23 bits here, which are marked in blue in this slide, are a part of the subnet, and the remaining trailing 9 bits are part of the host. So this is what and this is how IP addresses would be represented if you are talking about using subnets.